Annuity due is an annuity where first payment is made at the beginning of first period. To further understand, so let's draw a cash flow diagram. So we have here periods. So this is the first period. So from 0 to 1 is your first period. This is the beginning of the first period, while this is the end of the first period. So for annuity due, the payment starts at the beginning of the first period. So if we recall, for ordinary annuity, the payment starts at the end of the first period. While here, you have to start your A here at 0. So for the formula, you have two formulas just like the ordinary annuity. So for the annuity due, the formula for the present worth, or P, is equal to A times the quantity of 1 plus I raised to n minus 1 over I times 1 plus I raised to n minus 1 plus 1. While for the future worth, or F, we have F equals A multiplied by 1 plus I raised to n plus 1 minus 1 over I minus 1. So we can, in this formula, we can see a pattern here. So just like the ordinary annuity, for the future worth, your denominator is only I. And if we compare the formula for the present worth and future worth, here, for the numerator, the exponent of 1 plus I is n minus 1. While for the future worth, the exponent is n plus 1. Then here, you have to add 1 to the fraction, while here, minus 1. So, in order to easily memorize or to master the formula, if you have for present worth n minus 1, then plus 1 here. While here, if n plus 1, you have to subtract 1 here. So that's a technique to recall the formula easily. And copy the rest. Just remove this expression, the long expression 1 plus I raised to n minus 1, just retain I. In that way, you could easily recall the formula. So we have the same element. A stands for the annuity, or the series of equal payments. Your N is still the number of payments. I is the interest rate per interest period. So I is given by the formula R over M. So R is the nominal rate of interest. And M is the number of compounding per year. So now that we are done with the formula and the definition, let's solve an example. So a man will deposit 200 pesos with the savings and a loan association at the beginning of each 3 months for 9 years. If the association pays interest at the rate of 5.5% compounded quarterly, find the sum to his credit after the last deposit. So let's identify the given first. So 200 pesos will be deposited at the beginning of each 3 months for 9 years, meaning to say 200 pesos are the equal payments. So we have A equals 200 pesos, then it will be deposited for at the beginning of each 3 months, so 4 times a year for 9 years. So the number of payments N is equal to 36. Now, the nominal rate of interest is 5.5% or 0.055, and it is compounded quarterly, therefore M equals 4, and I equals R over M equals 0.055 over 4 equals 0.01375. Now, so find the sum to his credit just after the last deposit. So we have here the required is the sum after the last deposit, therefore it is F. So the cash flow diagram will look like this. So you have a total of N of 36. So your payment starts here. So you have a total of 36 payments. So the cash flow diagram will look like this, and the sum of all the payments F will be here. So to solve for the problem, we have the formula for F equals A times 1 plus I raised to N plus 1 minus 1 over I minus 1. So by substitution, we have 200 times 1 plus I over N plus 1 minus 1 over I, so 0.01375 minus 1. So F is equal to 200 times 1 plus I raised to N plus 1 minus 1 over I minus 1. So the future amount is 9,363 pesos. And that is the sum to his credit after the last deposit.